Scientists have discovered a gigantic ring-shaped structure in space which is so big it challenges our understanding of the universe. Experts at the University of Central Lancashire say it's 1.3 billion light years in diameter and appears to be roughly 15 times the size of the Moon as seen from Earth. Structures that big shouldn't exist, according to one of the guiding principles of astronomy.
Scientists have made significant strides in our understanding of primordial galaxies located at the edge of the universe. Initially, there was skepticism about the validity of these findings, with some researchers questioning whether closer galaxies could be misidentified as more distant ones. This prompted extensive research and collaboration among scientists worldwide, leading to groundbreaking results that exceeded expectations. The evidence has confirmed that these galaxies are genuine, showing no signs of discrepancies. This remarkable advancement is primarily due to the capabilities of NASA's James Webb Space Telescope. This advanced instrument not only provides an exceptional perspective of the universe, but has also succeeded in observing the oldest galaxies ever detected. Astronomers are now able to state with confidence that the light from these galaxies has traveled over 13.4 billion years to reach Earth, offering invaluable insights into the early universe. The findings suggest that these galaxies existed in the universe when it was only 350 million years old, highlighting the rapid formation of the earliest generations of galaxies. Observing the spectra unfold as expected has validated the existence of these galaxies at the true limits of our observational range, exceeding what Hubble was capable of detecting. But why was it so important to confirm that these galaxies actually occupied the early universe? Firstly, the discovery verifies Webb's capacity to undertake one of its most significant roles, examining the early universe through light that has traveled for such a long time that the universe's expansion has elongated its wavelength. This light stretching is referred to as redshift. The longer the light moves, the more it shifts toward the red end of the electromagnetic spectrum due to the universe's expansion. This indicates that redshift can serve as a distance measurement, and that early galaxies should exhibit light demonstrating extreme redshifts, with their light extended into the infrared range, which is the specialty of Webb. The finding has fundamentally challenged our cosmological understanding. Secondly, the existence of these galaxies compels us to create something more powerful than Webb and investigate whether the Big Bang occurred at the time we believe it did. When researchers examined the data gathered from Webb's near-infrared camera and near-infrared spectrograph instrument, they discovered that 4 out of the 6 galaxies do indeed exhibit extreme redshifts. They reached this conclusion because the spectra from these galaxies lacked the characteristic signature of heavy elements, such as carbon, indicating that Webb is observing them as they appeared when the universe was merely 300 to 500 million years old. The universe currently stands at approximately 13.8 billion years old. According to our current understanding of cosmology, the epoch of reionization began roughly 400 to 500 million years after the Big Bang. This period marks the moment when the universe, once dark and filled only with neutral gas, began to light up as clouds of hydrogen and helium slowly came together to form the first stars and protogalaxies. It was the dawn of structure, when the cosmic fog lifted and tiny pockets of matter became the building blocks of everything we see today. Scientists believe this process was gradual, stretching across many millions of years before galaxies grew large and complex enough to resemble the familiar spirals and clusters we recognize in the modern universe. That's why the discovery of well-formed galaxies just 500 million years after the Big Bang, as revealed by Webb, is so puzzling. These galaxies shouldn't exist so soon. The timeline doesn't fit. If galaxies were already massive, organized, and bright only a few hundred million years in the cosmic history, it means our models of how the universe evolves are missing a crucial piece. So what is truly happening here? A sense of urgency is now swept through the scientific community. Researchers are racing to explain how these galaxies can be reconciled with the standard model of cosmology, which includes ideas like inflation, the rapid expansion that occurred fractions of a second after the Big Bang. But this effort is running into serious challenges. The Big Bang theory, despite being the leading explanation for decades, has long had gaps and contradictions that many quietly acknowledged. For example, it appears to violate the first law of thermodynamics, which tells us that energy cannot be created or destroyed, only transformed. If that law holds universally, then what sparked the Big Bang? Where did the energy come from? No one has an answer. And the questions don't stop there. We still do not fully understand how the universe made such a dramatic leap out of its dark ages during the epoch of reionization. How exactly did the first stars ignite? What was the trigger that suddenly transformed an opaque, lifeless cosmos into a universe blazing with light? These remain mysteries. And now, with Webb showing us galaxies nearly as old as the Big Bang itself, the mysteries are only multiplying. Imagine this. Galaxies that should be primitive, chaotic clouds of stars are instead appearing mature, structured, and in some ways resembling our own Milky Way. They are too big, too bright, and too evolved for their age. A recent paper put this to the test, carefully analyzing these early galaxies, and the results confirmed what many feared. Their maturity is real. These galaxies really are older and more developed than our models allowed. This leaves scientists in an uncomfortable position. If these results are correct, then something is missing in our understanding of cosmic history. And yet, they can't dismiss the Big Bang theory outright, because multiple lines of evidence still support it. The cosmic microwave background radiation, discovered in 1965, remains one of the strongest clues. It's often described as the faint afterglow of creation, and its precise pattern lines up beautifully with predictions made by the Big Bang model. There's also the fact that the universe is expanding. We know this because galaxies are moving away from us, and the farther they are, the faster they recede. This fits exactly with the idea of an expanding cosmos that started in a dense, hot state. On top of that, the predicted abundance of light elements, hydrogen, helium, and lithium, matches what we actually observe in stars and gas clouds. Put all these clues together, and the Big Bang still looks like the most powerful explanation we have. But then Webb arrived, and the conversation changed. In one of its most striking findings, NASA announced the detection of a cluster of 7 galaxies at a redshift of 7.9, meaning we are seeing them as they were only about 650 million years after the Big Bang. These galaxies are not isolated. They form a protocluster, a group that astronomers believe will eventually grow into something like the Coma cluster, one of the largest and most massive galaxy clusters in the modern universe. This discovery is stunning for 2 reasons. First, it shows that galaxies were already grouping together into large-scale structures far earlier than expected. Second, it suggests that galaxy evolution can be much faster and more dramatic than our models predict. To make matters even more exciting, astronomers have been able to measure the velocities of these galaxies with great precision, confirming that they are gravitationally bound to one another. In other words, they are not just coincidentally near each other, they are part of a growing cosmic city destined to merge and evolve together. One NASA scientist compared it beautifully, saying these galaxies are like tiny droplets of water in a stream, merging together to form a powerful river. That image captures it perfectly. We are watching the first great rivers of the universe come together far earlier than anyone thought possible. So what does this mean for the Big Bang? It doesn't necessarily prove the theory wrong, but it does show that our picture is incomplete. Perhaps the Big Bang happened, but the way we describe it, the timing, the physics, the sequence of events, is flawed. Just as Newton's laws of gravity weren't exactly wrong, but turned out to be a small piece of Einstein's broader theory of relativity, the Big Bang may also be a limited chapter in a much larger story. This is why the discoveries from Webb are so important. They are forcing us to question not only how the universe began, but also how quickly it grew and organized itself into galaxies and clusters. The fact that we can now directly observe these ancient structures, frozen in light that has traveled for more than 13 billion years, means we are no longer guessing. We are watching history unfold before our eyes.
And this is only the beginning. As Webb continues to peer deeper, we expect to find even more early galaxies, some possibly older and more mature than these 7. Each new discovery will either strengthen the Big Bang framework or reveal more cracks in it. Either way, we're on the verge of a revolution in our understanding of cosmic origins. So where does this leave us? We know the Big Bang theory explains many things: expansion, radiation, and light element abundances. But we also know it fails to explain why galaxies are already so well formed so early. Perhaps there was a process that accelerated cosmic evolution, something we don't yet understand. Perhaps our timeline is wrong, or perhaps the cause of the Big Bang itself is different than we imagine. For now, the only answer is patience. We have to keep collecting data, keep refining our models, and keep testing our assumptions. But if history is any guide, the answers may come sooner than we expect. The universe has always surprised us, and with Webb, those surprises are arriving faster than ever.